Good morning, Sayanu. Good morning, Bhumika. Good morning, Varshita. Muskan, good morning. Good morning, Ramya. Good morning, Amali. Okay, listen. Good morning to all of you. Yes, portions are easy, okay, to get the marks. These portions are easy to score the marks, but little bit difficult to understand. Little bit difficult to understand. Whatever my portions are there, the whole thing. The whole thing. So therefore, better you write and practice at home. Better you write and practice at home. Okay, yes, right. Last class we have discussed about this. I kept it as it is. See that grad u I have written. Grad u. By definition, it is said to be u dot dr is equal to u is a vector function or a vector field. U is a vector field. Already you have understood about vector means what is that vector field and other things. If possible, today or tomorrow, I will going to send you all these notes. Okay, most probably within next class. I will send the first chapter notes. The first chapter notes, I will send it to your email. Okay, only the link I will send it. It will be there in the Google Drive. You can download, no problem. Okay, so study well at home. Right time to study because you don't have any other work to do, and as well as you don't have the practicals also. Only the theory classes that we are taking up. It is easy to score the marks because you can study well at home. Finish it off the portions, whatever it has been covered on the same day, so that it will be easy to score the very good marks. Okay. My sincere advice, you study well at home. Yes, these are the concept already I have covered. U dot dr is equal to du. Dr is the known thing here. Okay, u is a vector. Just I will take up here, no? Del u by del x. Okay, this is du. Du function, this is u dot dr. Therefore, u is equal to how much? U is equal to here. I cap is a unit vector. You are aware of that, I think, if so. So one more thing that I want to first, you see that here, this concept you have to learn it. Okay. Once you understood about these concepts, especially in the 9:30 morning classes, 9:30 class, there is some shadow is coming up here. So try to adjust. After 10:30, this problem will not be occurring on the table. Okay. Before 9 o'clock also no problem. 9 to 10:30, this problem is occurring. Almost every week we are having this kind of problem. Yes. The light is incidenting on my table. Okay, yes, right. This is grad u. This is grad u. Okay. I into del u by del x plus j into del u by del y plus k into del u by del z. It is grad u. Last class already it has been mentioned. Already we came across all these ideas. Now today's portion that I have to take up differential operator. Differential operator. This is pronouncing as del. Written like this. Del operator. Differential operator is a del operator. Okay, del, pronouncing as del, writing as like this. Don't write delta. Delta is different. Delta is ulta. Okay, reverse way. Okay, it is not delta, it is del. Del function, this is del function. You know about the differentiation, mathematics differentiation from second PUC you have learned now. From second PUC, differentiation. Differentiation, d by dx. D by dx. That is only a scalar operator. D by dx is not a vector operator. It is a scalar operator, d by dx. It is a differentiation concept. But whereas this one, It can be used for a vector also and for a scalar also. Okay, that's why I said slightly difficult to understand the concept. But once you understood, easy to score the marks. Very easy to score the marks. Okay. Yes, differential operator. What is that concept here? Already we know that grad u is equal to something. If you want, I will write that grad u here. Grad u can be written as del u. Don't forget. I will write that. Grad u can be written as del u. That is del u. Del u is equal to, or grad u is equal to I cap. Same thing. Del u by del x plus j cap del u by del y plus k cap. I, j, k are unit vectors acting along x-axis, y-axis and z-axis. I cap is a unit vector acting along the x-axis. J cap is a unit vector acting along the y-axis. K cap is a unit vector acting along the z-axis. Okay. K cap into del u divided by del z. This is del into u. This is a concept. Okay. This is del u. Therefore, within the bracket, whatever I have written so far, within the bracket, whatever I have written, that is called by the name of del, nothing else. That is a del operator. Therefore, del is equal to how much? Del is equal to I cap del u by del x. We had to solve the problems on all these concepts. Easy to score the marks, I said. One problem will be there, very easy. J cap del u by del y plus k cap del u by del z. This is del operator. This is called by the name of del operator. I told you already, d by dx is a scalar operator. It is a scalar. We are using only for the scalar differentiation. That is d by dx. Whereas this del function we are using for the vector as well as for the scalar. We can use it for the vector and we can use it for the scalar. If you are using for a scalar, that is called by the name divergence. If you are using for a vector quantity, it is called by the name the curl. Therefore, this can be operated on a scalar. I will write, if you want, I will write. This is a definition concept. Now, del can be operated on a scalar. On scalar. Del can be operated on a vector. If it is acting on a scalar, this is called by the name divergence of a vector. Divergence. This is, of course, it is acting on a vector quantity only, but product is said to be a scalar. Okay, I don't know whether you have understood or not. It is acting on a vector quantity only, but the product is said to be a scalar. The product is a scalar quantity. Here the product is a vector quantity. This is called by the name the curl. The product is said to be a scalar here. Here the product, after taking the operator, the product, the last answer is said to be a vector quantity in the case of a curl. Now we have to think, what is the physical significance of this? We are asking for 4 marks or 5 marks question. Define divergence. Define curl of a vector. About that, we have to solve the problems again. About this, we have to solve the problem. About this also, we have to solve the problem. Stokes theorem, Gauss theorem. We are asking for about 2 marks question. Both are important. These are also important. Then we are asking here, it is even for 5 marks, 6 marks also that we are asking. Okay, define divergence, define curl of a vector. What are their physical significances? Explain. We are asking. So be careful. Learn it properly in today's portion also, in today's class also. Yes. See here. I supposed to teach you about the divergence and curl. Divergence and curl I supposed to teach. Okay, I said already. Okay, divergence means what is that, sir? Divergence means del, it is an operator, dot a vector quantity. Then whatever we are getting an answer here, that is called by the name the divergence of this vector. calculate the divergence of a given vector. Like that, we are asking the problem. Curl means what? Curl of a vector means del operator cross product of a vector quantity. Then the product is a scalar here. Here the product is a vector quantity. Vector analysis is a little bit difficult. But once you understood the concepts, all these things are easy. So divergence, del operator is there. So that's why I said dy dx, your dy dx value is there now, dy dx, differentiation. Dy by dx, y is equal to x square. Calculate dy dx, right? So those ideas we are using only for a scalar quantity. We cannot use it on a vector quantity. But whatever the del product is there now, this del operator, we can use it on a scalar also, we can use it on a vector also. But here, under vector quantity, there are two operations are there. One is a dot product, then you will get a scalar quantity. The other one is said to be a cross product, then you are going to get a vector quantity. This is a basic idea. Now, let us think in the form of divergence of a vector quantity. Divergence of a vector quantity, important for your examination. Curl also important for your vector quantity. That is for your examination. This is important. It is a vector quantity. So the first one, divergence of a vector function. Divergence of a vector function. Okay, in between, don't okay, left out the class here. If you are left out the class, not so easy to understand it. Okay, divergence of a vector function. I will consider a vector field here. Which is the vector field? V of x, y, z represents a vector field. Represents a vector field. Let us consider it is a vector field. V, x, y, z, it is representing a vector field. Okay. At a given point, which is that point? This is the point. It is a vector field at a given point in a certain particular region also. Vector field means it's not somewhere else here. Here it's said to be some region. In that region, there is a vector field is present here. At a given point, V, x, y, z is a vector field. It is representing a vector field. Okay. At a given point, you have to say that at a given point. Which is that point? X, y, z is a point. Okay, if you want me to write, I will write it here. Okay, let V, x, y, z represents a vector field at a point. Since it is a little bit difficult, I will write all the concept, no problem. At a point that is x, y, z. Okay, in certain region of space, no problem. The divergence of V is defined. How to define? Dot product we have to take. The divergence. The divergence of vector V, that can be written as div V. Okay, we are asking the problem now. In that case, we have to think all these concepts. Div V can also be taken as del operator. You can write a vector now, no problem. Dot, it is a vector. Of course, del operator is a vector. Okay, dot, a vector quantity. A vector quantity. That I supposed to define. How much is this? I supposed to define. How much is equal to that? So therefore, del dot V. Del dot V is equal to del. Already we know that del value. I will show you. This is the del value. Is it right? We know already. Differential operator, del operator, we know this. This is the del value. Del value, I will write it here. This is the del value. What is that? I del by del x, j cap, del by del y, k cap, del by del z. This is del dot product. What is this V? A vector quantity, don't forget. This vector is acting along x-axis, y-axis and z-axis. Therefore, I will write I cap Vx component along the x plus j cap component along the y plus k cap component along the z. Okay. Now we have to multiply. I into I is 1. I dot I is 1. I dot j is 0. You know about that? Cos theta is coming here. Cos 90 is equal to 0. Cos 0 is 1. I dot I into cos 0. Cos 0 is 1. Therefore, I dot I is equal to 1. Don't forget about this. I dot I. According to your vector analysis, I dot I is equal to 1. J dot J is equal to 1. K dot K is equal to 1. But I is a vector acting along the x-axis, y-axis and z-axis here. I, this is J, this is K. This is x-axis, y-axis, this is z-axis. What is the angle between x and y-axis? 90 degree. Y and z-axis, 90 degree. X and z-axis, 90 degree. Therefore, I into j is 0. I dot j. I dot j is equal to 0. Because I into j into cos 90. Cos 90 is always equal to 0. And j dot k perpendicular to each other. K dot I. Even reverse way also. Don't forget A dot B is equal to B dot A. You know that A dot B is equal to B dot A. This is I, this is J. So J dot I is also equal to 0. This is also equal to J dot I. This is also equal to K dot J. This is also equal to I dot K. Don't forget these basic concept of your vector analysis taken from your second PUC vectors. Second PUC mathematics vectors or your degree portion. Okay, this is the basic. Therefore, if you are multiplying this and this, I dot I will get. This and this is equal to 0. This into 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 this, j into j is equal to 1. This into this is equal to 0. K into I is 0. K into j is 0. K into k is 1. So use that concept and write the answer. Therefore, del dot V is equal to, del dot V is equal to here. I dot I is equal to 1. Therefore, del Vx, partial derivative, don't forget, del Vx divided by del x. When we are solving the problem, we will come to know that. Plus, here, j into j, del Vy divided by del y plus del Vz divided by del z. This is a divergence concept. Divergence of a vector. This is divergence of a vector. This is a scalar quantity. It cannot be a vector quantity because it is a dot product. Because it is a dot product. Dot product is always a scalar quantity. Okay, this is one concept, carries 2 marks. Explain the divergence of a vector function. Explain the divergence of a vector function. This is a concept. I explain the divergence of a vector function. Clearly you can see, no problem. Divergence of a vector function. All these things are important for us to solve the problem also. These are the concept. It is important to solve the problems. Okay, that's all. Next, I had to teach curl. That is a vector quantity. Product is a vector quantity. Okay, finished. I'm taking up very slowly. Yes, because I know that all these concepts are slightly difficult. Yes. Now I will take up curl. Okay, curl of a vector. Curl of a vector field. Curl of a vector. The product is a vector quantity. The product certainly it is a vector quantity. Curl of a vector field. Let me consider a curl here now. Let me consider a vector field. For a vector field, that is V. Of course, x comma y comma z. Okay. This V can also be written as, how to write? I into Vx along the x component, and I cap I have written, plus j into Vy plus k cap into Vz. You know about this. Okay, for a vector field V, the curl of that one is given by curl V is equal to del cross V. This is curl. Del cross V. This is curl. Del cross V means that is equal to here. Del, already you know that. What is that del value? I cap del by del x. Okay, I will write it here. That is equal to, because the space is insufficient. Therefore, I cap del value we have to write, nothing else. Shall I show it again? What is the del value? This is del. I into del u by del x plus j into del u by del y plus k into del u by del z. So therefore, I cap into del by del x, del by del y, k into, these are all unit vectors, I, j, k, del by del z. Unit vector, unit vector, unit vector. Cross, it is not a dot product, it is a cross product. Cross IVX plus JVY plus KVZ. KVZ. Now I have to take the multiplication. I suppose to consider the multiplication. Let us go back to your second PUC portion. Your determinants. Not only that, even in the case of your where it is maybe under Kirchhoff laws, okay, of electrical network. In all those cases, we have used the cross products here. All those cases. Okay. This value is equal to how much? This value is equal to here. It is a cross product. I suppose to write like this, determinant. Okay. This is unit vector I, j, k are the unit vectors, columns. Here it is del by del x. This is del by del y. This is del by del z. Then this is Vx, Vy along the j, along k, Vz. You know how to expand this. You know how to expand this. But while expanding this one, we must be very carefully. We have to do the expansion. So be careful about the expansion here. This is plus, this is minus, this is plus. Is that right? Taken from your second PUC portion, mathematics. Plus I minus j plus k. Then we are supposed to take the multiplication. Is that right? Determinants expansion, you are aware of that one. But before that, it is a dot product. Already we have understood. This is a cross product. You must be very carefully, we have to think. I cross j. I cross j is equal to k. Don't forget. J cross k is equal to next one, I. K cross I is equal to j cap. If you want, I will write a note taken from your second PUC. I said this one. If you are writing ulta, oh, this is not equal to k, because A cross B is equal to minus of B cross A. You know that A cross B is equal to minus of B cross A, correct? Again, taken from second PUC, determinants concept or vectors, or first PUC physics. A cross B is equal to minus of B cross A. Therefore, if I'm writing here J cross I, if I'm writing J cross I, if I'm writing, it is equal to minus K. K cross J, if I'm writing, K cross J, if I'm writing, that is minus I cap. I cross K, if I'm writing, then that is equal to minus J cap. These are basic ideas. Now use that idea and expand this. Let us expand this one. These are basic. Okay. Now I have to expand this one. That is equal to, what is that? Curl V is equal to how much? It is equal to I cap into, of course, plus I cap into, right? Leave this column, leave this row. If you are aware of already all these concepts, very easy. Leave this column, leave this row, remaining 4, whatever the portions are left behind here now, 4 factors. You have to multiply these two principal diagonal values minus the remaining 2. Okay. So focusing on this, leave this, this one and this one I had to leave. Now I had to multiply these two, del Vz divided by del Y. So if I'm explaining the second PUC portion, don't get upset. This is I, this is J here. Okay, leave this column, leave this row and column. The remaining thing is present here, this much. I don't want to write the still more explanation like that of second PUC. No, already you know about this. Directly we can write del Vz divided by del Y minus del Vy divided by del Z. Okay, minus J, here it is a minus J here, minus J into, leave this column, leave this column, leave this row, leave this row, leave this column. Remaining things are this, this and this. These are the 4. This one, this one, this one and this one. Now multiply the principal diagonal thing. Del Vx divided by del Z minus del Vz divided by del x. Correct now? J, I have left out this one. Del Vz. There is a mistake. Correct. I left out this one. Now del Vz minus j cap, that if I am taking a plus here, no problem. Whatever I have written, it is right. If I am taking a plus here, whatever I have written, it is right. So anyhow, I have written minus j cap here. I will correct it, no problem. Okay, minus j cap del Vz divided by del x. Okay, del Vz divided by del x minus del Vz divided by del x. This one I have left out. This one, del Vx divided by del z. They are one and the same. Whatever I wrote in the beginning, only thing is plus I have to put it there. Okay, minus sign if I am taking outside. That's okay. Plus k cap. Plus k cap. Leave this third column. First row. Leave these two. Then remaining 4.
Excuse me, sir.
Okay. So here, del Vx divided by del y minus of this del Vy divided by del x. Electrodynamics will be very easy if you know the mathematics. Okay. If you want to learn physics properly, you must be aware of mathematics. Even in higher class, MSc level also. Okay. A person who knows mathematics, very good knowledge of mathematics, if they are possessing, then physics will be very easy. Okay. Therefore, usually a physics person can teach even mathematics also, but cannot be the vice versa. Okay, if you want to learn physics, we have to learn first mathematics, then we have to learn physics. Yes, anyhow, so this is the concept, del Vz divided by del y. Okay, hoping that you have understood. I cap, I can take it afterwards also. This I cap can be written here, or j cap can be written here, no problem. It's left to you how to write. I can write like this, no problem. That is equal to, what is that? Del Vz divided by del y minus del Vy divided by del z I cap. Unit vector afterwards, let me write. I cap. Okay. Minus j cap. If I am writing plus j here, if I am writing plus j cap, okay, I will write plus here. Okay. Plus, then this is reversing. This is del Vx. That one only I have written here. Del Vx divided by del z minus del Vz divided by del x into j cap. Plus the last one, del Vx divided by del y minus del Vy divided by del x into k cap. This is curl. This is a vector quantity because ijk are present here. This is a vector quantity. The product is a vector quantity. But divergence, if you are taken, the product is a scalar quantity. Divergence. Okay. Have I understood about this? Now I have to take up physical significance. Okay, altogether we are asking for about 6 marks also. Let me see that in your question paper, do you have 6 marks question? I don't know, but Mysore University, we had even 6 marks, 7 marks, 9 marks, all these type of questions. Okay. Each problem there it was carries 4 marks. I have to see your question paper pattern. Okay, we'll see that. So depending upon that, we are going to ask the questions here. Okay, we will set the question paper like that only. The questions must be set in such a way that what is the marks it has been carried. So depending upon that, we are going to set it. Okay, yes, right. So this is the concept. Okay, now I will take up physical significance of gradient, physical significance of divergence, and physical significance of curl. That's all today's portion. Enough. That's all. Okay. All right. Then by next class, I will send the notes. This is your syllabus. This is your syllabus. Okay. See that scalar and vector fields. The gradient of a scalar field. The divergence and curl of a vector field. The physical significance of gradient, divergence, and curl that I have to teach now. Okay. Statement of theorems of Gauss and Stokes that I will take up in the next class. We have to solve the problems. Here we have to solve the problems. Okay. Plenty of problems are available here. But the number of problems here it is very less. Here it is still very less. Very less here. Okay. Theory portion only 10 hours is there. Here also. Theory portion 2 hours. Okay. I am thinking first I will cover this portion, 2 hours portion. Then we will take up this one and continuously we can do this. No problem. Okay, before that, let me finish it off these problems also. Let us finish it off. Okay. Yes. Right? Now, one chapter almost discovered without problems. Without problems. That's why I said it is easy to score the marks. It is easy to score the marks. Only thing is you have to write and practice at home. Now, first idea, physical significance. Physical significance of gradient. What is the physical significance of a gradient function? What do you mean by that? Why we require that? Where we are using that? That is the meaning of physical significance. Let me consider a vector field represented as a gradient of a scalar point function. A gradient of a scalar point function I will going to consider. Then the line integral of the vector field between the 2 points, the line integral of a vector field, don't forget, the line integral of a vector field. You know about the line integral? Line integral of a vector field between the 2 points in the region is independent of the path. Somewhere else you have heard about these points now, taken from your first year degree portion. Conservative force field, heard about that conservative forces, conservative field. And the line integral, if it is not over a closed path, if it is equal to 0, it is a conservative field. We are using all these ideas in the case of your electricity. These concepts are more helpful in the case of our electricity portions. That's why I said electrodynamics. This is electrodynamics. So point number 1, where we are using the line integral of the vector field. The line integral of the vector field. Line integral of the vector field. I have chosen a vector field and I have taken the line integral of the vector field between the 2 points. Between the 2 points. Between the 2 points. If it is independent of the path, okay, this is independent of the path. If it is independent of the path, joining the points. Joining the points. Point number 1. Point number 2. So what is that? The line integral of the vector field between the 2 points in a vector region, vector field region. If it is independent of the path, Joining those 2 points, independent of, means the 2 points are there, either like this or like this if you are choosing. Then line integral remains same if I'm choosing. Either if this is a wire or something, along this direction if you are calculating, or along this direction if you are calculating, if they are one and the same along the vector field here, it is independent of the path lining the, joining the 2 points here. Then point number 2, the line integral of the vector field over a closed path is 0. If it is equal to 0, then it implies it is a conservative field. If these two conditions are holds good, it is a conservative field. From first PUC physics also you have studied about the conservative field. Gravitational field is a conservative field. Electrostatic field is a conservative field. Okay, which is having this is a conservative field. If these two conditions are holds good, it is a conservative field. Then it finds a very important applications. Using all these ideas, we are using the important applications in electricity. If you are writing this much is enough. This is physical significance of gradient. Okay. Is it clear? Physical significance of gradient. Now I have to take a physical significance of the divergence. Physical significance of divergence. Physical significance of divergence. Okay, today I will cover both the things that I will cover it. Still we are having more than 12 minutes time is there, we can cover it. So physical significance of divergence. What do you mean by this physical significance? Again, what is the necessity of studying about this divergence, where it is helpful, all these things. Divergence of a vector function at a point means the net outflow per unit volume, that is given as the net outflow per unit volume per second. That is a meaning at a given point. At that point, how much is the net outflow per unit volume per second is present. That is representing for the divergence of a physical quantity. Divergence of a vector quantity. Divergence of a vector quantity means the net outflow per unit volume per second at that point. So what is that meaning? Again, we have not understood what is this meaning here. It means that if the liquid or any fluid dynamics, if the liquid or any fluid, if it is expanding from a source, this is the point. If the liquid, if it is flowing like this outside, this is the point. The liquid flow that takes place like this, then I can say the liquid is expanding. Or fluid is expanding. It is flowing outside. Then this point is called by the name source. This is from here the liquid is flowing. From here the fluid is flowing. When do you say this one? If the divergence is positive. So don't forget, if the divergence of a vector quantity is positive, divergence of a vector quantity is positive, there is a point from there it is flowing outside, meaning the fluid is expanding, or the point is representing the source. Okay. Now, if the divergence is negative, what is that meaning? If the divergence is negative, this is the point under consideration where the liquid is flowing like this towards the point. Then I can say the fluid or the liquid is contracting. Then this point is not a source here. Thermodynamics you have already studied now. It is not a source now. It is called by the name the sink. Just like your wash basin. Okay. After washing our hand, the water is flowing towards the sink, the wash basin. The fluid is contracting here. The liquid is flowing towards the point. Here the liquid is flowing away from the point. Here the liquid is flowing towards the point. Liquid flow towards the point, then the point representing the sink. When do you say this one? If the divergence is negative. When do you say this one? If the divergence is positive. No, sir. I will get divergence is equal to 0. Okay, if the divergence is 0, what do you mean by that? If the divergence is 0, then I can say the point, neither it is a source, nor a sink. It is not a sink, not a source. When do you say that one? If the divergence is equal to 0, it is not a source, it is not a sink. The fluid is not expanding, the fluid is also not contracting. It remains as it is. That is the physical significance of this. It is applicable even for the current flow. I said liquid flow. Not necessarily the liquid flow. We can apply this one for the current flow also. For the current flow also that we are using all these concepts. All these ideas that we are using even in the case of current flow. Okay. Yes. Third idea, number 3. What is that number 3? The physical significance of curl. Okay. Physical significance of curl. Of curl. What is that? The maximum line integral of a vector per unit area at a certain point is called by the name of curl. So what is that curl? Okay. The maximum value of the line integral, I will write some concept, line integral of a vector field. Yeah, at a certain point, at a particular point, at a certain point. This is called by the name of curl. That is the meaning of curl. Curl, curly hair, we are going to say that. Is it right? Curly hair means rotated, turned, rotational, turned, like that. Circular. This is the meaning of curl. Curl means that is a meaning. Rotation. Okay, that is a meaning. So what do you mean by this? What do you mean by this? If the curl V is non-zero, for example, point number 1, if curl of V is not equal to 0, then I can say the vector field V is having a circulation, or maybe circular motion it is having. It is rotational. It is having circular path, or circulation is present, or it is rotational. It is non-conservative. Non-conservative. That is the meaning. Non-zero. If it is non-zero. If the curl V is 0, if you are getting 0 value, curl V, in the same region, of course, then I can say the vector field V is irrotational. And is conservative, of course. This is non-conservative. Here it is conservative. Conservative. So the meaning, for example, in the case of river, if this is a river, you have seen some particular points where there is whirlpools are said to be existing, means the water is go on rotating like this. Is it right? Where there is a larger depth of water, if it is present, it is rotating like this. In the case of bathtub, once the bathtub is filled, and if you are open that one, wherever the water is flowing out here, the water is rotating like this. In all these cases, we can apply the curl. We can apply the curl in all these cases. This is the physical significance of curl. So this is the physical significance of curl. Just I am showing. See there. Understand the concept. Next, I had to take up Stokes theorem and Gauss divergence theorem. Maybe for about maybe 10 minutes or maybe 15 minutes. 15 minutes maximum. I will teach you about those two. Then I have to start either the problems I have to start, or I have to start with some other portion also. Some other portion. So study well at home. Okay, by next week I will send the notes of all these concepts. Whatever the portions are covered, I will send the notes. Go through the concepts. Thank you, Afra. Umehani, not present today. I don't know whether she is there in second sem or fourth sem. Still, the names could not be able to recognize it properly. Okay. Once the offline classes are started, then only we will come to know that.